Namaskar दोस्तों, welcome back to VNP networking tutorials. In today's video, we are going to understand the default TTL value in iBGP and how the TTL changes as packet travels through multiple routers. In this video, I will explain everything using a simple 4-router topology. So by the end, you will clearly understand why iBGP uses TTL 255, which is the default value, how TTL decreases hop by hop as they travel through the network, and why iBGP sessions can work across multiple routers. So let's get started. Let's first understand our topology. We have 4 routers connected back to back. Router R1 is connected to router R2 using the subnet 10.1.1.0/30. Router R2 is connected with router R3 using the subnet 10.1.2.0/30, and router R3 is connected to router R4 using the subnet 10.1.3.0/30. Our focus is on the TTL value of a BGP packet generated by the router R1. Please remember, TTL stands for time to leave. It is an 8-bit field inside the IP header. The maximum possible value is 255. You cannot have value greater than 255. Its purpose is to prevent packets from looping forever inside a network. Every layer 3 router decreases the TTL value by 1. So when TTL reaches the value 0, the router discards the packet and usually sends an ICMP time exceeded message. So let's start discussing more on this topology. On router R1, the BGP packet is created. At this moment, the TTL value is 255. No router has processed the packet yet, so the packet leaves R1 with its original TTL value of 255. You can think of TTL as a countdown timer. Initially, the timer starts at 255. Now, the packet arrives at router R2. As soon as router R2 forwards the packet, it performs layer 3 routing. Every layer 3 forwarding operation decreases the TTL value by 1. So 255 minus 1 is equal to 254. Now the packet leaves router R2 and goes towards router R3. The TTL value is 254 at R2 currently. This is exactly what our diagram shows. So in the next step, the packet reaches router R3. Again, R3 performs the layer 3 forwarding. The TTL decreases by 1. So 254 minus 1 is 253. So that is the current TTL value on R3. The packet now leaves R3 with the TTL value of 253. Please notice the pattern. Every router subtracts exactly 1, the TTL value. Finally, the packet reaches R4. Again, the router performs layer 3 forwarding. The TTL value decreases one more time. So 253 minus 1 is equal to 252. So on R4, the packet now has a TTL value of 252. So our complete TTL progression for this topology is: on R1, the TTL value is 255. On R2, the TTL value is 254. On R3, the TTL value is 253. And finally on R4, the TTL value is 252. This is exactly how IP routing works. Now, one very important point. Many engineers believe that iBGP packets always stay at the TTL value of 255, but that is not correct. The packet starts with the TTL value of 255. As it crosses every router, the TTL value is reduced by 1. What remains different from eBGP is the starting TTL value, not the decrement process. The decrement process is identical for every IP packet. Now let's discuss the most important question. Why does iBGP use a default TTL value of 255? Unlike eBGP, where neighbors are normally directly connected, iBGP neighbors belong to the same autonomous system. These routers may travel several hops apart. For example, in the same autonomous system, in an ISP network, you might have 10, 20, 50, hundreds of routers, and you want to form an iBGP. So if you have an iBGP session and with the default TTL value of 255, so this will make sure that the packet will not, the TTL value will not become 0 and the BGP session can be easily established. Cisco therefore uses a default TTL value of 255, allowing the packet to travel across multiple routers without expiring. This is one of the major difference between eBGP and iBGP. For comparison, eBGP default TTL value is 1 and iBGP default TTL value is 255. This means an iBGP packet can travel through many routers before its TTL value expires and becomes 0. I hope this video was informative and thank you for watching. See you in the next lecture.